once I like it, okay, then what I do is I can export this. Now I have different options for exporting. I'm going to pick the PPM data image. It goes into any image manipulation package. I could name it something other than Fred, as it says here, and just do an OK, and I have my PPM image. Are there any questions so far?
So we can export the image as a PPM file or whatever you said that. But I'm just thinking like which format we should choose to get the best resolution.
Okay, the PPM format is high, that's natural, whatever your data is, so it's perfectly good resolution. Okay. When we do the data manipulation, the highest resolution is going to be TIFF. So you would do a TIFF image from, and you wouldn't ask for any compression. The other thing you can do is if you don't have the information, if your images aren't aligned and you don't align them in your astronomy software, you can do it graphically, and what you want to do then is enable your overlay axis enable to give you a grid and save that when you export it as a PostScript file. And what you'll be able to do with that is then align everything on that grid, okay, on those labels. Okay?
For example, if we have to zoom on any particular feature in our image, so can we do that also in this one and then export it?
Okay, actually, Harsha, I would keep them the same and try and zoom in later, because the PPMs are going to be the natural format, so you'll have all the information there. So now I've shown you a way to stretch images. Some of you have DS9, and some of you are going to have, I don't know if anyone's got Karma here on this machine, you do at work. So go ahead. Anybody want to stretch their images? Tackle it?
Yes,
yeah.
indubitably.
Let's go. So in this group, we have people who are doing X-ray images, for example. So instead of having filters, you have a lot of different data. So the idea here is to turn into different segments of your wavelength regime images, okay? And it's best to have at least 3 images, and you can probably, in the X-rays, right, do 5. Okay, so if you're doing CO data or radio H1 data, then what you do is instead you divide it up into velocity channels. So you pick a bunch of velocity channels and you put them together and divide up your velocity range into different images. And then you'd have 3 to 5 different images to color. So everybody has black and white stretches now? Okay, cool. You guys, what are you going to be showing us?
Planetary nebula.
Planetary nebula, taken with what camera?
16-inch optical.
Okay, and where was it, Blair?
It was taken at Mount Wilson Observatory.
Okay, and you took it.
I did.
Erica?
I'm working with XMM X-ray data.
Yay!
Yay! Of a supernova remnant.
Okay, how many images are you?
I've got it filtered into 3 bands right now.
3 bands. And then Harsha?
I'm working on a supernova remnant which has a pulsar inside, and basically like I have filtered into 3 energy bands. So I'm going to like give colors as you suggested, and it's like 5 observations actually.
Now what we're going to do is make the color images now that we have our black and white stretches. You can do this in Photoshop if you like. It costs money. You can do this in the GNU image manipulation package GIMP. Okay, so GIMP doesn't cost you any money and it works on all platforms. So we're going to open these up in GIMP. I have a few different images here. I also have that stretch that I did before. So let me bring that one up. Now, I know for the X-ray people that you've already smoothed your images. Radio people may not have already smoothed their images. So in order to get rid of some of this dimpling, blow this up to probably 2000, and you can see some of this dimpling. So what you can do to get rid of this, and it's going to be a bit, maybe make you a bit uncomfortable, but you can use one of the filters. Here's a filter called Blur, and there's a Gaussian blur. And a handy one to use is the RLE blur. And you can do a Gaussian blur. I can preview it here. As you can see, this is a bit of work to do it. So generally, just to apply it is easier. This you have to experiment with. I think I found that Gaussian blur of 3 was very good. And what you're trying to do is aim for retaining structure in your data while smoothing out those dimples. And some of you who are doing X-ray data might want to try a bit of that as well, even though it's already smooth. You've still got noise in your data, and you can try which blur works for you. Now, it makes some of the structure lost. We are looking into different ways to remove the noise and then put back the fine scale structure, the spatial structure on the fine scales. But right now, in the imaging packages, this is what you can use. And in the end, once you've made your image, you can also do the following. You can use a filter and then do an enhance and sharpen. Now the problem with the enhance and sharpen, when you do that, we'll do that in the cosmetic section, stage 4, it can create artifacts. So you have to be very careful about that. Are your stars very square or very round? Oh, they're probably round enough. If your stars are very square, you want to do a Gaussian blur, and then that will make them round. Here's a very important point. If you have very large images, like more than 500-700 pixels across, then you want to develop a strategy without investing a lot of time. This is the way artists do it. They make thumbnails, they make thumbnail sketches. What that means is you reduce your image in size. Okay, so instead of working at a painting this big, you work on something this small and you make a bunch of different ones. It's a whole strategy that you're going to work out. You're going to pick which one looks best. And then what you're going to do is you're going to, of course, have kept notes throughout the whole thing. And you're going to say, that strategy works best, that's my best image, and then you'll apply it to your full resolution data. So if your images are too big, this is the time to make a thumbnail. I think, oh, there it is. It's too big. So what I do is I come over to Image, Scale Image, and if I'm working, here's another very important point. If I'm just going to produce something for the web, I want my resolution to be 700, just 72. It used to be called DPI, for dots per pixel, but it's really PPI, pixels per inch, sorry, dots per inch and pixels per inch. Okay, that's fine for the web. When you're going to go publishing, you want this to be about 330. Okay, so that's what you're going to do if you're going to be publishing this image and making TIFF images, as we mentioned before. But when you're doing a thumbnail, 72 is just fine. But you don't want to have 4,000 pixels. What you want to do is have, 500 pixels. And then you would save that and crop it as well. Another thing that you would like to do is, at this point, crop into your object, and you can see by using the crop tool that you can select specific positions for your bottom left-hand corner and your upper right-hand corner, and that means in all 3 to 5 of your images you can select the exact same pixels and therefore align them very easily. So once you've done that, these are going to be your full resolution black and white images that you're going to use. I hate to tell you this, you might not like them the first time around, and you might have to go right back to KViz and start again, but hopefully it will be okay.
So Jan, I still need to align my images. How should I do that, and when should I do that?
Okay, this is a really good time to do it before you even do your thumbnails, to do it on your full resolution images so you don't have to do it again. Okay, so you only have to do it once and then make your thumbnails after that. So to align your images, there's 2 ways to do it. Blair, do you have the coordinate axis around?
I do not.
No, but you have stars, right?
I do have stars.
Okay, so I'm going to show you how to do layers. And when we do the layers, you can apply that to your full resolution images as well. And you'll be able to align your images and then make your thumbnails. There's a